Algebra represents one of the first courses where students transition from concrete to abstract reasoning. But a report in 2015 by the Mathematical Association of America stated the following: freshman and sophomore mathematics and statistics courses function as gateways to many majors. They are crucial for preparing mathematically and scientifically literate citizens. Yet each year, approximately 50% of students fail to pass college algebra with a grade of C or better. One of the difficulties experienced by students transitioning from arithmetic to algebra is the concept of variables. The secret to variables is to realize that they are simply placeholders. Which do you prefer? X squared plus 3x plus 2 equals 0, or box squared plus 3box plus 2 equals 0, or underline squared plus 3 times underline plus 2 equals 0. They're all the same. You can put any number or expression into the placeholder, which is the x in the first equation, the box in the second equation, and the underline in the third equation. If we put in 1, we see on the left we get 6, on the right we have 0, so they're not equal. That means 1 is not a solution of that equation. If we plug in 4, we see we get 30, we get 16 plus 12 plus 2, which is not 0, so that 4 is not a solution of the equation. If we plug in negative 1, we get 1 minus 3 plus 2, which is 0, so negative 1 is the solution of the equation. If we plug in 10, we get 100 plus 30 plus 2, or 132, which is not 0, so 10 is not a solution of the equation. If we plug in 1/2, we get 1/4 plus 3/2 plus 2, or 3 3/4, which is not 0, so 1/2 is not a solution. If we plug in negative 2, we get 4 minus 6 plus 2, which is 0, so negative 2 is a solution. The only numbers that make the equation true are the numbers negative 1 and negative 2. Now the identity x cubed plus 2x squared minus 4x minus 8 is equal to the quantity x minus 2 times the quantity x plus 2 squared becomes box cubed plus 2 box squared minus 4 box minus 8 is equal to the quantity box minus 2 times the quantity box plus 2 squared. Let's check this by plugging a number into the box. Let's say 3. If we plug in 3 on the left, we get 25. If we plug in 3 on the right, we get 25. The two sides are equal. If we plug 10 into the equation, into the identity, on the left we get 1,152. On the right, we get 1,152. Let's try negative 5. If we plug negative 5 into the left, we get negative 63. If we plug negative 5 into the right, we get negative 63. No matter what you plug into the box in an identity, the two sides will be equal. The use of geometric shapes and symbols represents a small step along the path from concrete to abstract reasoning, which might be useful for some students. Variables are one of the first impediments that students face when they start learning algebra, but variables are simply placeholders. And once students understand that and practice that, then understanding algebra becomes easier. A study titled Development of Abstract Mathematical Reasoning, the Case of Algebra, studied the influence of age and gender on concrete reasoning versus abstract reasoning using a simple algebraic task. And the conclusion of the article was the following: our results indicate that the transition from concrete to abstract reasoning represents quite a long process, even for simple algebraic tasks used in this study. Teachers and educational policy makers should be aware that it's not enough to learn about equation rearrangement in mathematics at once. It should not be presumed that students master this skill quickly and that they can easily apply it in other contexts, such as problem solving in physics. On the contrary, teachers should use every opportunity to encourage students to use formal reasoning, both pattern recognition and effective application of mathematical rules and known procedures. Practice understanding variables and understanding the rules of algebra make the process much easier for students. The effective application of these rules helps move a student from concrete to abstract reasoning.